In this session, we will discuss GARAOTUS Cloud Platform for atmospheric science. So high-performance computing has been used in many researches and applications. So one of the significant use of HPC is for atmospheric science to improve the accuracy and the timeliness of short-term weather warning, forecast, as well as regional and global climate and ecosystem prediction. Now, new emerging technologies such as container microservices, data analytics, machine learning, and AI have been used broadly in enterprise hyperscale computing environments. So then the question comes to how to implement these modern architectures into the HPC to accelerate and improve the work of atmospheric science and analysis. So that we believe it is worth to rethink how the infrastructure could be built. So first, you might be familiar with the HPC architecture like this. So you can see the login nodes, job scheduler, and lots of compute nodes to deliver the computing power. So either CPU or GPU. And you will have a high throughput interconnection network in the system, as well as the parallel file systems. So this is the traditional HPC infrastructure. And it has actually worked very fine in the past 2.5 decades. To support lots of academic and institutional researches. But due to this unique architecture, it's kind of quite independent from the outside world. So especially the commercial and the enterprise domain specifically. And so the HPC is mostly used by academic and institutions for researching purpose. So that's why when you put on the glasses of modern architectures, such as cloud native, microservices, and big data, you might find that traditional HPC has limited orchestration to service or jobs. And it's very hard to support hybrid architectures, namely bare metal physical servers, virtual machine, container, into a single platform. So it's also very difficult to do the auto-provisioning, re-provisioning, and system upgrade, etc. So also we find it's also not easy to build and manage the multi-sites or several HPC clusters in an environment for diverse groups and users. Also, there are no workflows and CI/CD support to enable the CI/CD environment. And it also lacks of a better way to manage the data. So that's why we would like to introduce GARAOTUS Cloud HPC solution, so which supports hybrid architectures, no matter it's container, virtual machine, or bare metal. The platform managing all the infrastructure beneath to provide IT, AI, HPC, and the data warehouse as a service to the multi-tenant groups and users in an orchestration way, as well as to support a better isolation security, robustness, and performance. Besides, the cloud platform also provides workflow capability to design your own process and the microservices to design your CI/CD environment. So second, the cloud data warehouse will be able to synchronize and manage your data to achieve the need and purpose of data locality, mobility, and data security. Also, when talking about auto-provisioning, we not only to save the time and the cost for handling and managing the request from your user, but also to prevent some mistakes and faults from the manual process. So It also supports the single user interface in a multi-site cluster environment. So this architecture, we know some of these on HPC are taken care individually. However, the GARAOTUS Cloud Platform is a comprehensive end-to-end solution to provide a single universal platform to address most critical concerns that a traditional HPC needed to be transformed. So here I would like to illustrate more how self-service and automation, auto-provisioning workflow work together. So you can see the user can log into the platform wherever they are, and then browse the service catalog, and then find the service and the resources they need, adding to the request list, and send to approval. So once it goes to the IT administrator, your supervisor or manager, to review your request, and then they will do the approval or reject your request. So once it's approved, the GARAOTUS Cloud Platform will do the provisioning and then notify the user by email or SMS. And then the user will be, they will know the service is already on and ready and available for them to use. And also, is also for the IT administrator will be able to monitor the system status and the usage via the dashboard on the platform itself. So this self-service portal integrates the predefined services and the advanced automation process, allowing users to request and receive IT resources without people intervention, and offer the capability of monitoring, managing, and controlling those resources in a better orchestration way. Another key feature of GARAOTUS Cloud Platform is to offer unified management for all the resources available to users. So it means that the platform is able to manage multi-sites, and it will give you the flexibility to design your own job workflow. So leveraging the right resources from different sites or clusters based on resources availability. Which, for example, we have site A, site B, and C. So when the computing power of site A is fully consumed, so you actually can direct the job to the site B or site C to do the job. So the resource could be used more efficiently. It could be also based on the architectural availability. So what does it mean? It means that the job maybe needs some special resources, such as AI or machine learning. And the job can actually could allocate it to the right cluster, providing that capability or resources such as GPU cluster. And finally, the job execution could also depend on where the data is. Because of the purpose of data locality, mobility, or just simply because of the data security you may concern, the platform provides you the ability to orchestrate your jobs and the data in a more flexible way. So this unified platform is not just for managing your multi-site, multi-cluster. It also provides a simple and a unified user interface to log in. So users log into the platform, and then they can enjoy and play with whatever, wherever, whenever the resources are available and managed under the platform. So now you might have already got an idea that the GARAOTUS Cloud Platform is to turn the traditional HPC into a modern cloud-native environment with a hybrid architecture. So that actually delivers self-service, automated, standardized, and optimized platform to provide resources for your research and jobs. Furthermore, we have developed atmosphere analysis as a service on top of it to offer an even friendly and easy interface, a step-by-step process for running the numerical weather prediction, so such as WRF model. So this would definitely bring values to atmosphere users, so who are no longer spending time and efforts figuring out what's happening in the infrastructure and the system. Instead, they can spend most of their time focused on study and the work of their research. So here I would like to explain more the basic flowchart of a WRF simulation. It actually consists of four parts of process. So first is the external data sources. So we need to get the external data like geographic data, global data from specific institution, or the sources on the internet maybe. And then once we have that external data, we need that data to be fed into the WRF pre-processing system, or WPS. We need to get the output from WPS for WRF simulation. So by the way, the WPS does not support MPI, it's a serial processing. And then when it comes to the WRF simulation, we have two executions, real and WRF. Finally, we will get the simulation result, the WRF out file. And this job of simulation is actually accelerated and supported by MPI processing. And finally, once we get the WRF out file generated, it will go to the post-processing system, which actually to present your simulation result in the way that you want it to be displayed. So next, I will show you some examples, some samples, examples of a WRF result. So okay, now let's go through the atmosphere analysis again, the process from a user's point of view. So first, this atmosphere user will log into the platform and switch to as a service, where he can request a computing process or a job workflow running on an atmosphere-specific cluster. So a friendly and easy of user experience will guide the process from the external data input to the checklist needed for this process, and preset the parameters needed for this simulation. And also, finally, you will get or any additional owner setting file need to be considered for this simulation result to be generated. As a user, you could also, on the platform, to cancel the service or query the service to preview the result, download and share the result, or you can manipulate the data and convert the data format for other process. You are also able to know and monitor your computing status, as well as to browse and displaying the result in the way you like it to be. So imagine each block in this process is kind of microservices in a container, so which could be defined and preset on your own. So for example, you might like to have a Docker container with a single node computing power to do the job of word pre-processing because it does not support MPI process, right? And then you send the job to the Singularity container running on HPC to do the actual multi-processing simulation work. So, and finally, you present the result in a Docker container, so leveraging the GPU resources to display it in a three-dimensional way. Or you can save that result on a public storage cloud, such as AWS S3, to share with the third party. So this innovative AI as a service is based on the platform, which enables the system engineer the ability to standardize and optimize the whole infrastructure, as well as we offer the capability to the administrator to manage, monitor, and orchestrate all the computing resources available to the user. So thank you for your participation and the interest in GARAOTUS Cloud Solution for Atmospheric Science. Together, we forward faster. Thank you.